At this time, I'd like to introduce our presenter, Richard Roberts, Industry Affairs Manager for Honeywell Life Safety and System Sensor. Richard, take it away.
Thank you, David. Good morning or good afternoon, depending on which time zone you're in. I'd like to thank everyone for taking time from their busy schedules to attend today's informative presentation. Even though this webinar is being presented by System Sensor, it is not a product sales pitch. Rather, it's an unbiased presentation that provides a basic introduction into mass notification and emergency communication systems. Hopefully you'll gain a fundamental understanding of what a mass notification system is, or more commonly referred to as MNS, and emergency communication systems, or referred to as ECS. During the next 45 minutes, we'll explain the concept of mass notification and look at how it evolved. Cover some of the types of facilities where ECS and mass notification systems are typically installed. Review the history and development of these systems in Nfpa 72, and of course that is the National Fire Alarm and Signaling Code. Then we'll go through some of the basic but very important requirements in the 2010 edition of Nfpa 72. And lastly, we'll review some, not all, but some of the key changes relating to mass notification and ECS systems in the 2010 edition of Nfpa 72, which was just published in October of 2012. So let's kick it off by looking at what is mass notification. This is a relatively new concept for the life safety community. Mass notification began from the inability of emergency first responders to communicate with and direct building occupants during an emergency situation. Now, thinking of an MNS as a gigantic public address system that provides pre-recorded or text messages to people over a wide area is really misleading. A true mass notification system involves a lot more than a collection of loudspeakers and sending text messages. The overall purpose of a mass notification system involves an integrated effort to save lives and minimize injuries during emergency situations such as fire, natural disasters, and terrorist attacks. Mass notification can be defined as a technology that provides real-time information to groups of individuals within buildings, campus-style settings, geographic regions, or an entire nation. So mass notification is intended to give emergency first responders a clear understanding of the situation in order to take appropriate action so that the building occupants are able to remain safe. The mass notification concept actually started from a U.S. military incident that occurred overseas. It prompted the U.S. Department of Defense into developing a comprehensive mass notification program. The incident occurred in June of 1996, where a U.S. military building located in Saudi Arabia was bombed by a truck carrying over 5,000 pounds of explosives. The building housed about 2,300 American military personnel. Tragically, 19 people died and 372 were injured. This incident caused the U.S. Department of Defense to make rapid changes to its emergency planning by creating the Unified Facilities Criteria Mass Notification document in 2002. The UFC document outlines the design, operation required for mass notification systems in military bases that are located inside and outside of the United States. The current version of the UFC document was published in 2008 with revisions in January of 2010. Now, the UFC mass notification document can be downloaded at the link referenced on this slide. Since that incident in Saudi Arabia, there have been other high-profile acts of violence. One of the first to occur was in 1999, and that was the Columbine high school massacre in Colorado. Needless to say, everyone remembers the tragic events of 9/11. There have been numerous university shootings as well, most notably at Virginia Tech and Northern Illinois University, and most recently, the 2012 Newtown, Connecticut shootings. There have been other emergencies that could have benefited from a mass notification system, such as the 2011 Joplin, Missouri tornado and the tornadoes that occurred this year as well. For many years, mass notification systems were installed in military facilities only. However, in the private sector, the demand for mass notification has been rising steadily since the attacks of September 11, 2001. Mass notification systems have been and are being installed in many college and universities across the U.S. Mass notification systems can be used in many commercial and industrial or even governmental occupancies where there is a need to inform or instruct people during an emergency situation. Several examples are public schools, public mass transit facilities, manufacturing plants, and large corporate headquarters. So how did mass notification get into Nfpa 72? The process started in June of 2003 when the Air Force petitioned Nfpa to establish a mass notification project. The Air Force wanted Nfpa to spearhead this important project for several reasons. First, a fire alarm system is an effective platform for mass notification because it's a highly regulated and extremely reliable type of system. The installation, testing, and maintenance requirements for fire alarm systems are well established. Also, after many years of hands-on experience, emergency first responders are very familiar with the operation of a fire alarm system. Lastly, and probably most importantly, using a fire alarm system as a platform from MNS avoids the additional cost of installing and maintaining multiple systems. Even though launched by the military, these systems are now being driven by the private sector and national consensus codes and standards. Now, mass notification first appeared in the annex of the 2007 edition of Nfpa 72. It's important to remember that annex material is not part of the mandatory requirements of an Nfpa document. Instead, annex material is included for informational and explanatory purposes only. After the 2007 edition of Nfpa 72 was published, the Nfpa Standards Council created a technical committee to begin work on the development of a new chapter for the next edition of the standard. In October of 2009, the 2010 edition of Nfpa 72 was published, containing a new chapter called Emergency Communication Systems. That's Chapter 24. The new Chapter 24, covering ECS systems, has requirements for array of systems, including mass notification. Now, before we start reviewing some of the new requirements in Chapter 24, let's understand what an emergency communication system is and how it differs from a mass notification system. Okay, first, a mass notification system is used to provide information and instructions to people in buildings or other structures using voice messages, visible signals, text messaging, graphics, or other communication methods. A mass notification system is somewhat similar to a fire alarm voice evacuation system, but it covers emergencies other than fire, such as severe weather alerts, terrorist attacks, or workplace violence. Whereas an emergency communication system may consist of several subsystems, such as fire alarm, mass notification, or two-way communication systems, such as firefighter telephones and area of refuge communication. As you can see, an ECS system is used for numerous emergencies. That includes fire and mass notification. NFPA 72 requires an ECS system to be classified as either a one-way or two-way system. This slide from NFPA 72 provides a very nice illustration of the various ECS classifications, and this should be helpful in trying to understand the differences between an ECS and mass notification system. So an ECS system is classified or organized into 4 sections. First, section 24.4, colored in beige, applies to one-way systems such as fire, voice evacuation, and several types of mass notification systems. Section 24.5, colored in light green, addresses two-way in-building emergency communication systems. Section 24.6, colored in orange, covers the information, command, and control equipment. These requirements apply to the communication methods and equipment used to send and receive signals between the protected premise and central control stations. And lastly, Section 24.7, colored in purple, covers the performance-based design requirements. Basically, Section 24.4, 24.5, and 24.6 are prescriptive requirements, whereas Section 24.7 is a performance-based design requirements. So as you can see, Chapter 24 outlines the design, installation, and testing requirements for emergency communication systems, including mass notification. Before reviewing the various elements of an ECS system in more detail, let's take a break for our first poll question. David?
All right. Thank you, Richard. It is time for a poll question. So if you look on your screen at this time, what we're curious with or curious about today is what are your biggest challenges with implementing voice of Ecs systems? So, could that be passing intelligibility? Maybe understanding the code. Richard outlined NFPA, and there's the UFC as well. Designing the system, integrating multiple systems. We'll talk about that a little bit later. Or is it other? If it is other, I would appreciate if you'd use that chat box and just send me what is the other challenges that you're facing. We will take a few moments. We would like all of you to vote on this. And Richard, we do have a couple of questions that have been posted by our audience. I will encourage you, ask questions at any time, and we'll answer them in the order received. Richard, the first question that's posted is, are there any states or building model codes that require mass notification?
Good question. I get that quite frequently. Right now, I am unaware of any states or model building codes that require an ECS or mass notification system. However, I do know that the state of Massachusetts and the state of California requires a in-building fire emergency voice communication system, and that's for education occupancies, and really a fire voice evacuation system is almost could be considered a backbone for an ECS or mass notification system. Also, the 2012 edition of the International Fire Code and the International Building Code require in-building fire voice communication systems in education occupancies, and I think that's when the occupant load is only over 30 people. So I guess that's a long answer to your question, but I hope that provides the information that the submitter was looking for.
Okay, good. Second, we'll answer a couple of questions here while everyone's voting. 88% of you have voted, so we appreciate that. And I failed to mention we will publish the results here in just a moment once we get through these first questions. So, Richard, the second question presented is the 2013 NFPA 72 code requires that a designer document ambient sound pressure. What information does the designer need And what are the design guidelines for the calculations? Can we help this guy?
Off the top of my head, I don't know what that is.
Okay.
Certainly, if they want to send me an email, I will open up the NFPA 72 code and take a look at it and get back to you with the requirements. I think later in this presentation, I do cover some of the documentation requirements, but certainly I would encourage everybody on the call today or on the webinar today to purchase a copy of NFPA 72, or better yet, the NFPA 72 handbook, because the handbook really provides a lot of additional explanatory material in there that explains in more detail some of the requirements and the basis for some of the requirements. So,
okay, very good. Thank you, Richard.
Yeah, if they want to send me a email, I can give them more information.
And Richard's contact information will be presented at the end of the presentation. So, Richard, I have posted the poll question results, very mixed amongst the top 4 there. Looks like both integrating multiple systems and passing intelligibility are in a narrow lead, but certainly designing and understanding code are closely following. And then 7% did click other, and we had some people that did submit what their others are. Let me just go through those quickly. It looks like it's not required by my clients. They won't budget for it, is the biggest challenge, or is one of the biggest challenges. Another one is, let's see, around pricing. Everyone thinks M&S is a good idea, but again, don't want to pay for it. Let's see, differences of the UFC code applications between jurisdictions, so maybe a little code conflict there, it sounds like. Let's see, download a sound meter app and take readings while systems are running as normal. Oh, okay. Maybe that reader's or that attendee's trying to help us with that first question. So what information does designer need, and what are the design guidelines? And his response is download a sound meter app and take readings while systems are running as normal. So anyway, let me take the poll down. Thank you for responding. All of you will have a couple more poll questions later in the presentation. And Richard, we're back to you.
Thank you, David. During the rest of the presentation, we're going to cover some of the ECS and mass notification requirements in NFPA 72. Now, because we only have 45 minutes, there's not enough time to cover all the details and requirements and exceptions to the requirements in NFPA 72. And sort of reiterate what I just said a minute ago, I highly recommend that everyone go out and purchase a copy of NFPA 72, or better yet, the handbook for all the requirements for fire alarm, ECS, and mass notification systems. And also, if you're doing a military mass notification systems, download that UFC mass notification document. So let's look at the elements of a one-way ECS system. These systems provide information to people in buildings or outdoors using audible, visible, or graphic means. The first classification is an in-building fire alarm voice evacuation system. This is your traditional fire alarm voice system, and these requirements have been in NFPA 72 for many, many years. The second type is an in-building mass notification system. The requirements incorporate the guidelines from the annex material found in the 2007 edition of 72. Also, many of the requirements have been correlated with the military's UFC mass notification document. Another type of one-way ECS system is a wide area mass notification system. It provides real-time information to people outdoors using a public address type of system. These systems are typically used in large university campuses or military bases. And lastly, a distributed recipient mass notification system is intended to communicate directly to targeted individuals or groups of individuals via email or texting. These people may be in a building, a group of buildings, and across an entire geographic area, or they could be worldwide. It's important to point out that these systems are not to be used in lieu of the required audible and visible notification appliances. However, they should be integrated into a mass notification system whenever possible. Now, let's look at a two-way ECS system. These systems give emergency first responders the ability to directly communicate with each other and building occupants. These systems are used to exchange information and to communicate information such as instructions to firefighters and building occupants, gathering information on the emergency or fire, and to give assurance to occupants that help may be on the way. Now, the most common two-way ECS system is a wired firefighter telephone system. They are typically found in high-rise buildings such as hotels, office, and apartment buildings. These requirements have been in NFPA 72 for many, many years. However, in recent years, fire departments are using radios to communicate with each other instead of the traditional wired telephone systems. This type of system is called a two-way radio system. And lastly, an area of refuge is where people who are unable of self-rescue can safely gather and communicate with emergency first responders during an evacuation or other emergency situation. These areas are generally located in stairwells or near exits. It goes without saying that every facility is unique and has specific risk. Facility stakeholders must clearly understand the potential risk to their facility and design a system that accounts for them. The key to understanding and defining these risks is to perform a risk analysis before designing and installing an ECS system. Chapter 24 is very explicit about requiring a risk analysis for each facility. For example, Section 24.4.221 points out that each mass notification system shall be designed for the specific nature and anticipated risk. The next section requires the designer to consider both fire and non-fire emergencies when determining risk tolerances. The next several slides show how the risk analysis will establish the system voice message priorities, determine the notification zones within a building, and identify where intelligible voice messages are required. Continuing with the requirements relating to a risk analysis, Section 24.4.22.4 requires the risk analysis to be used as the basis for the development of an emergency response plan. Section 24.423 requires the emergency response plan to be developed in accordance with two NFPA documents. First, NFPA 1600. That's the standard on disaster emergency management and business continuity programs. And the second document is NFPA 1600. That's the recommended practice for pre-incident planning as part of the design and implementation of a mass notification system. The takeaway from the last two slides is that every mass notification system is unique and therefore is really not a one-size-fits-all solution. An area of considerable confusion and misinformation is whether a mass notification system is permitted to override the fire alarm system. The risk analysis is the central point that determines the priority of the mass notification message. The risk analysis will identify what emergency situations, if any, will take priority over the fire alarm evacuation signal. For example, if a manual pull station has been activated, it might be a terrorist action to have people leave the building and walk into an exterior threat. In such a case, a mass notification message may override the fire alarm signal to redirect occupants to stay in the building. Now, Section 24.4.210 is very clear. The mass notification priority levels shall be established on the basis of the risk analysis. And the next four sections on the slide provide specific guidance when a mass notification message is permitted to have a higher priority than a fire alarm signal. The takeaway for this slide is a mass notification system is not always permitted to override the fire alarm system. It's only when determined by the risk analysis is a mass notification system permitted to override a fire alarm system. Now let's discuss voice intelligibility. As I mentioned a minute ago, the overall purpose of a mass notification system is to save lives and minimize injuries during an emergency situation. Therefore, it's imperative for individuals within buildings to clearly understand the voice message. Intelligibility is really the percent of the message that is understood correctly. The main objective is for building occupants to understand the message and to take appropriate action to remain safe. Designing an intelligible voice system is very challenging, even for experienced sound designers. Knowing how to determine and predict intelligibility for each installation is extremely difficult. Therefore, we won't get into the details of laying out an intelligible voice system, because this could be a 4 to 6 hour course. Instead, we'll provide a basic understanding of what intelligibility is and point out when intelligibility is required. Nfpa 72 has required a fire alarm voice system to be intelligible for quite a few years, but it never mandated a specific level of intelligibility or a method of measuring it. Let's take a quick look at several key sections in the 2010 edition of 72 relating to voice intelligibility. First, Section 33126 defines intelligible as being capable of being understood, comprehensible, and clear. This definition is somewhat ambiguous, though, because what is clear and understandable to one person may or may not be to someone else. Section 2431 requires ECS systems to be capable of reproducing pre-recorded or live messages with intelligibility in accordance with Chapter 18. And Chapter 18 is the notification appliance chapter within 72. The key word in this section is capable. It's not mandating that voice systems provide intelligible voice messages. Rather, it's saying it must be capable, and it refers back to Chapter 18. And looking at Chapter 18, 18410 requires voice intelligibility in acoustically distinguishable spaces only when it's required. The key term here is acoustically distinguishable space. This is a new term in the 2010 edition of 72, and it came out of research conducted by the Fire Protection Research Foundation on how to design and measure intelligibility. So, what is an acoustically distinguishable space, or more commonly referred to as ADS? If you look at Section 33.2, it defines an ADS as parts of a building intended to have an ECS notification zone. Each ADS is distinguished from other spaces based on different acoustical environmental conditions, such as reverberation time and ambient sound pressure level. Essentially, an ADS allows the building to be divided into definable spaces, so the stakeholders are able to decide which spaces of a building require voice intelligibility. Section 18410.1 requires the system designer to identify acoustically distinguishable spaces during the planning and design phase of an ECS system. And 18410.2 says that each ADS may or may not require voice intelligibility. The takeaway here is that not all areas of a building are required to have voice intelligibility. It's during the design phase that stakeholders must establish which spaces of a building, as I said, if any, require voice intelligibility. Likewise, not all areas of a building may require other notification appliances, such as horns or strobes. It's the risk analysis that will determine when and where notification appliances will be installed. There are a number of factors that go into determining if a voice message is intelligible. A quality speaker is very important, but it's one part of an intelligible voice message. The two factors on this chart that apply to speakers are frequency response and harmonic distortion. Other factors that go into an intelligible message are signal to noise level, which has to do with the speaker spacing and the volume of the speaker output, and the ambient noise in the room or space. Echoes and reflections deal with the materials used to construct the building. For example, are the walls made of concrete block or drywall? And are the walls painted or covered with wallpaper? And finally, the talker and listener's ability will have an effect on the message. If the talker has a strong accent, the listener may not be able to understand what the talker is saying. Let's take a close look at signal-to-noise ratio. This compares the sound level being produced by the speaker with the ambient or background noise in the room or space. It's important to point out that once you get higher than 15 dB above the ambient, you start seeing a diminishing returns in regards to achieving intelligibility. That's why it's recommended to install more speakers tapped at a lower wattage as opposed to having less speakers, but increasing the sound output of each speaker. When installing speakers, each time the wattage is doubled, the sound output will increase by approximately 3 dB. This is illustrated in the top two drawings on the slide. Another important rule of thumb is each time the distance between the listener and the speaker is doubled, there is an approximate 6 dB loss in sound output. If you look at the bottom diagram on the screen, if the distance is increased from 10 to 20 feet, the dB level will go from 87 to 81 dB. As I mentioned earlier, the U.S. Department of Defense has its own document for the installation of mass notification systems in military facilities only. Many of the requirements in the DoD mass notification document are stricter than the requirements in Nfpa 72. One area where it is stricter is intelligibility measurement. The military UFC document requires all mass notification systems to verify the intelligibility by using a meter. Now, the reason for bringing up the USC requirements is because many people think Nfpa 72 requires quantitative measurements of the voice system. Unlike the military, Nfpa 72 does not require intelligibility to be verified. However, if intelligibility is required to be verified, Annex D of 72 permits the intelligibility to be verified by either using an instrument-based method or a subjective-based method. Instrument-based measurements use a meter to measure the intelligibility of a voice message in each ADS against an STI or CIS scale, whereas a subject-based method typically involves an individual or groups of people in a space listening to a voice message and determining if it is intelligible to them. Annex D 241 states the intelligibility of an emergency communication system is considered acceptable if at least 90% of the measurement locations within each ADS have a measured STI or CIS score. And section D244 and D245 explain what STI and CIS scores are. However, more often than not, subjective measurements consist of whether or not the local authority having jurisdiction is able to understand the voice message. Nfpa requirements have been designed to limit the complexity of designing an intelligible voice system by minimizing the potential for over-design. This chart is a nice illustration of how to use NFPA requirements to determine intelligibility. The process starts with identifying all ADSs within a building. Then the designer and stakeholders need to determine if intelligibility is required in each ADS. If intelligibility is not required, then the process is complete. However, if intelligibility is required, then you move on to the third step, which requires a method to see if intelligibility is achieved. And David, it looks like we're ready for our second poll question, so I'll turn it over to you.
All right, Richard, thank you. I'm going to go ahead and launch the poll question, and then we do have a couple of questions posted by our attendees, a couple I can answer, Richard, and a couple that will go to you. First, to the poll question, what are the biggest challenges with speakers for voice evacuation? So with speakers, and really check all that apply. Maybe it's that ease of integration into an amplifier, meeting the intelligibility requirements, mounting ease, passing loudness, that SPL output, or if it's other, similar to the last other that we had. If you do check other, if you could just send us a quick note on what that other might be, and we would appreciate all of you voting. I think we had almost 90% of you vote last time. We have a couple hundred people online with us today, so I think it's a good cross-section of the fire and specification communities. Richard, two questions that I can answer for the audience. Can they get a copy of this slideshow after the webinar? Let me just tell you, it will be archived. In fact, all of our webinars are archived at systemsensor.com under our training tab, so that should be posted by early next week. And then the second one I just wanted to answer is how do I get my CEU credits? Those should be via email, so the email that you use to register for the webinar, those will be sent in approximately 2 hours after the close of the webinar. You should check your email, and you'll see your CEU credit and certification of attendance there. I know different states require different things for that. Richard, the first question talks about you've talked about stakeholders. What is a stakeholder?
Good question. And it's one that I get quite often. It's any individual, group, or organization that has an interest in the successful completion of a project. Several examples are a building owner, an architect, fire protection engineer, and authorities having jurisdiction, and also insurance companies. Certainly, it can be other key people or organizations, but that's just a list of a couple that come to mind.
Okay. Next question posted here. Does NFPA 72 permit a mass notification system control unit to be interfaced with a fire alarm control unit?
Yes, it does. But the key here is that NFPA 72 does require an interface module between the fire alarm control unit and the mass notification or ECS system. So there are specific requirements in 72 that deal with that, but it is permitted.
Okay. All right. Let me go ahead. Just for sake of time, I want to make sure we get your presentation covered. I'm going to close the poll question, and as promised, we'll share these results. Richard, looks like a couple jump out here in a big way. Meeting intelligibility. So what are the biggest challenges for speakers? Meeting intelligibility, 77% of those voting, and we had 84% vote in this poll, indicate that meeting intelligibility is a problem and or challenge, and then also passing loudness. And let me just also cover those that have posted things for the other. So determining the spacing of speakers, where on the wall or ceiling, so where should they be located. Also the ceiling height provides a challenge. They're saying that the sound design, so phase cancellation and that Doppler issues. Let's see. Other understanding and reviewing designs for voice to make sure intelligibility and audibility are met when installed and during testing. So that's another one. Limited cable length per speaker circuit is a challenge for voice evac. So those are the others that have been posted here, Richard. So let me take the, thank you for participating, audience, in that, and let me take the poll question down. And Richard, we're back to you.
Okay, thank you, David. Another area of considerable confusion and misinformation is concerning strobes. Common questions are, what type of marking is required for strobes used for mass notification? Can the same strobe be used for mass notification and fire alarm signaling? What is the lens color? And what is the light intensity of a mass notification strobe? And lastly, are strobes required to be synchronized? Now, the following two sections provide a clear direction as to the marking on the strobe and permitting the same strobe to be used for fire and mass notification signaling. Section 24.4.2.20.3 requires strobes used for mass notification to have the word alert stamped or imprinted on the appliance and be visible to the public. If the same strobe is used for both mass notification and fire alarm signaling, Section 24.4.2.20.4 requires no marking or be marked with the word alert stamped or imprinted on the device. The color of the low strobe lens has been a topic of considerable debate for quite a few years. Many people are of the opinion the lens color should be a color other than clear. For example, the Air Force requires strobe lenses to be amber in color. However, amber-colored strobes may conflict with other strobe alerting appliances that are used in many industrial and manufacturing facilities. Therefore, the Nfpa Technical Committee decided that where the same strobe is used for both fire and mass notification signaling, they shall be clear or nominal white. However, if the risk analysis determines that strobes with colored lenses are required, Section 24.4.2.20.7 requires strobes with colored lenses to be marked with its listed light intensity, and the next section on the slide requires the light intensity of strobes to meet the requirements of Chapter 18. And finally, 24.4.2.20.10 requires strobes used for mass notification to meet the synchronization requirements in Section 18.5. The takeaway here is that the light intensity requirements and the synchronization requirements for mass notification strobes are typically the same as for fire alarm strobes. All of the Nfpa 72 requirements we've discussed thus far have been from the 2010 edition of Nfpa 72. In the fall of last year, Nfpa released the 2013 edition of the National Fire Alarm and Signaling Code. We don't have time to cover all of the changes, but we'd like to take a few minutes to cover a few important ones. The first change we'll look at relates to the development of the emergency voice message for one-way ECS systems. As we learned previously, an ECS system covers emergencies such as fire, severe weather alerts, and acts of violence. It goes without saying that a pre-recorded voice message to building occupants will be different for a fire emergency versus other types of emergencies such as acts of violence. During a fire, you want people to get out of a building, whereas you may want people to stay inside the building if there is a shooter on the campus or on site. Therefore, the Technical Committee added several new sections to deal with the content of voice messages. Section 24.4.1.1 requires voice messages to be developed for each specific emergency scenario, and 24.1.1.2 requires a message template to be developed for each message required in the above section. Now, the annex provides a lot of direction and examples for the development of an effective pre-recorded or live voice message. The next change we'll cover relates to documentation. Items 3 and 6 of Section 24.4.353 are new, and the committee expanded the requirements for improved and comprehensive documentation. The changes to the 4 sections referenced on the slide replaces the term risk analysis with emergency response plan. The reason I bring this up is because I referenced the 2010 edition requirements in slide 17 that state it's the risk analysis that determines the priority of the voice message. By definition, though, it's the emergency response plan that determines the message priority, not the risk analysis. Therefore, for the 2013 edition of the code, it replaced the term risk analysis with emergency response plan in the sections referenced on the slide. The 4 sections referenced on this slide add clarity to intelligibility and ADS requirements. As we discussed earlier, the 2010 code said that an ECS system must be capable of voice intelligibility, and each ADS shall be identified as requiring or not requiring voice intelligibility. 18.4.10.2.1 is a new section, and it states that intelligibility shall not be required in all ADSs unless required by other parts of this code, other laws, codes, or standards. Section 18.4.10.3 requires ADS assignments to be submitted for review and approval where required by the enforcing authority. Essentially, this new section requires written documentation listing the type of occupant notification for each ADS. For example, will occupant notification be accomplished by voice, audible tone, or visible appliances? If voice is required, will intelligibility be required, or is it not required? The next 2 changes we'll cover relate to intelligibility. 18.4.10.4 states that intelligibility is not required to be determined through quantitative measurements. However, if intelligibility is required to be measured, then 18.4.10.5 directs the reader to the methods described in Annex D of the standard. As we learned earlier, Annex D of the code permits intelligibility to be verified either by using an intelligibility meter or using a subjective-based method. Okay, David, looks like we're ready for our next poll question.
All right, Richard, this is our last poll question, and we're coming to the close of our webinar here. We've got about 11 minutes left, and we do have quite a bit of Q&A posted. So we're just wondering how we can help you. Richard obviously has spent quite a bit of time on the mass notification and ECS. Is there some way the system sensor can help you with this? Maybe a full-line catalog on AV notification appliances. We have a brand new brochure outlining mass notification and ECS appliances. We've got a volt drop calculator. We can give you information on that, or maybe our equivalent facilitation calculator, or perhaps you'd like a sales rep to call. So if any of those are of interest to you, we're going to leave that up there for a few minutes here while we go through some Q&A. Please go ahead and select those options that are most applicable to what your needs are today. So, Richard, I'm going to go through some of the questions that we have posted here. First one is you've talked about intelligibility meters, and one of our attendees is asking about any advice, one meter better than another one, or manufacturers of these devices.
I don't have a recommendation on which one would be best, but 2 meters that come to mind that I hear most frequently are Quest Technologies and Goldline. And you can go to Google and Google them and get information on those. But those are the 2 that come to mind. There may be more, but those are the 2 that I most frequently hear about.
Okay, good. Next question, where does Nfpa require that ECS be installed?
Good question. NFPA 72 does not require when to install mass notification or an ECS system. That is dictated by the building owner or a model building code. thing that you got to remember about NFPA 72, it's an installation standard. And when a manual fire alarm system or if a smoke detection system is required to be installed, or a voice system, that tells you how to install it. So you really need to go to your state model building codes or what the building owner requires.
Okay. All right. Next question. Where can someone find a good risk analysis template?
If you go to the annex of NFPA 72, there's a lot of information there on a risk analysis, and then as I said earlier in the presentation, there's 2 NFPA documents that give a lot of guidance to that, and that would be NFPA 1600 and NFPA 1620.
Okay. All right. Next question posted, if ECS system is used and it's also used for fire alarm notification, must it, and I'm assuming it means it meaning ECS, meet all of the audible and visual requirements of the fire alarm notification system?
Yes.
Okay. Easy answer. Good. When ECS are used, are multiple control stations required?
And Chapter 24, I think, permits a master control station, and you can have other control stations as well. But certainly, if one is in control, then the other ones can't be in control. But Chapter 24 addresses that.
Okay. All right. Do the requirements found in 18.4.10 apply to building fire evac systems with respect to ADS?
18.4.10. If that's intelligibility, it would relate to a fire alarm voice system.
Okay. All right. So if whoever posted that, if you need clarification, go ahead and post it again. The next question: can you provide some idea of cost, perhaps to a square foot, for a two-way radio ECS? Any idea about that, Richard? Or where could we send them?
I would not even begin to address that one. I mean, it's an ECS system. It can be very broad in what it's requiring, so I don't have an answer for that.
Okay, all right. So maybe check with local engineering or AHJ perhaps. Next question, how can a designer plan for non-fire risk?
I think if you, the first thing you need to do is gather all the stakeholders, and that would be the building owner, the insurance company, the local authority, and everyone put their heads together and figure out what the potential risks are for that specific facility. For example, I was speaking with a fire protection engineer, and he was at this university, and he was meeting with all the stakeholders, and he was thinking of the normal stuff, fire, weather alert, and acts of violence. But one of their major, if not their major, concerns for this specific site was the fact that it was very close to a dam, and if that dam had a leak or burst, you'd have a flood. And that was just an anticipated risk that he had never thought of, but it was very unique to that particular facility. So you just need to bring everybody together and have them communicate.
Mm-hmm. So it sounds like that risk analysis is key in that regard.
Mm-hmm.
Okay. If you do have any more questions, go ahead and post them at this time. Richard, we have one other question posted. You mentioned designing intelligible systems as complex. Where can someone go to get additional resources to help them with that?
Oh, good question. First, and I know I'm redundant, but I highly recommend using NFPA 72 Annex D of the code covers the planning, design, installation, testing of voice communication systems. Also the National Electrical Manufacturers Association, or NEMA, has an excellent publication. It's a guide called Emergency Communications Audio Intelligibility, and you can download a free copy of this informative guide at the NEMA website. That would be www.lifesafetysolutionsonline.com. And if you need, if that's not the correct address, then send me an email, and I'll get it for you. Another excellent source is to use a software design program to predict intelligibility of a voice system before installation. These software programs model acoustic properties for specific environments and speaker configurations. I know the one that System Sensor uses, I think it's called ECS, and I think you probably could go to the System Sensor website to get that, but there are other software programs out there as well, and it's a good way to help in the planning and design phase.
That's right. System Sensor does have a link to the ECS EVAC software. It's actually sold by another company, but it's one that we have looked at. And if you come to our site, or you can Google ECS EVAC as well, and you'll find the manufacturer of that. But our website also has the link. Richard, we have one other question posted here. With the demise of CI cable, what alternative design scenarios will arise? Code doesn't seem to be straightforward on this.
Yeah, that I wouldn't say it's a demise, but right now there is a definite hold on CI cable. I know that the the respective UL STP is working on this issue, and they're doing some research on it, but essentially for the use of CI cable, it has been greatly reduced because there's no certification for CI cables, and it's left many existing jobs in limbo because they've got many installations that they've got 10 out of 20 stories complete, and now they got to pull out the CI cable and go to another method. And I would recommend that you got to work with your local authority as well as the fire protection engineer on designing an alternative for that installation.
Okay, very good. So you see Richard's contact information there. If you do want additional information, maybe the webinar covered some topic you'd like to have a chat with Richard, or send him an email, that contact information is there. We are at the top of the hour. We do respect your time. So on behalf of System Sensor, I want to thank you for joining us today. As a follow-up, we do plan to send you a brief survey in about an hour. And remember, we'll send you that CEU certificate in about 2 hours. And we would appreciate your help in filling that out, specifically that survey out. We plan to reward one of you that completes the survey with a $50 Amazon gift card. Thank you for joining us today. This does conclude our webinar. Please have a nice rest of the day.
Have a great day, everyone.